my name is Marian, and I love to integrate, and that got so far that actually I started writing a book about it. So that's like the very current thing that I'm working on. And here under this link, you actually can find out more about that project, and you can get some samples of the book, and once it's ready, also the finished book, and also a lot of other related stuff about integration and about Java and so on. So check it out if you're interested. And basically, writing a book takes a lot of time and energy, and many times I have to ask myself, why have I actually started this? And the answer is also the motivation for this talk, and that's because throughout my career I've experienced too many projects where the topic of APIs and integrations was neglected up to the point it was too late, because once an API is in use, it's pretty hard to change. So maybe to make this a little bit more interactive, I would like to ask the audience. You can use chat or Q&A or whatever works for you. Have you had an experience with an API that you or your team developed that caused you some serious problems? Write me in the chat. Do we have anyone? Any brave people? Or then I also have a second question. Have you had experience with an API that was a third-party API that you had to use, and that API caused you some problems? Then you can write third-party or they. Okay, so seems like it's always the other ones who most of the time cause the problems. Yeah, I understand that we have many clever people here who know how to avoid problems, but still, I hope in some way you can spread the knowledge from this talk to those who make the mistakes, to those third parties. And before going to the first slide, I would like to do a little bit of a psychological experiment on you, and I will say something, and you should pay attention to what it triggers in your mind, right? So the thing I'm saying is API. Okay, got it? Now, how many of you, when I said API, started thinking about the REST API? Write REST in the chat. Okay. So I don't know what the percentage of the attendance this is, but basically I think it is enough to prove my hypothesis. Sorry, the hypothesis that REST APIs are pretty popular. And why? Because basically World Wide Web is all around us, and it's become something like lingua franca of the IT industry, which means that almost everyone in IT has to understand and support REST APIs in some way. And also, yeah, we had another web services standard, so-called SOAP web services. But unfortunately, when designing that standard, the people probably missed the KISS principle, keep it simple. That's why it wasn't as liked. And but just the fact that REST is so ubiquitous and popular doesn't mean that it's the best choice for everything. So that's one thing that you should bear in mind, that usually when a programmer needs to use an API, what he or she really needs is just calling some method or procedure. And the only caveat is that that procedure lies on a different machine in a different process. So what you really need is a remote procedure call. And there are great technologies for this, for example, gRPC and others. And these technologies let you abstract away from networking details, protocols, and encodings. You get efficient encoding out of the box, so a lot you save a lot of trouble. Another thing that can happen is APIs are quite commonly used to integrate microservices or in general applications within one organization, within one company. And there can be quite many parts to be connected. And for such cases, you want to have loose coupling so that you can easily switch one part for another one. And for this, for loose coupling, a good solution is to use some messaging infrastructure, some messaging broker like Kafka or some cloud queuing system. So that's another alternative to REST API. Of course, it has some risks because messaging is asynchronous, and that means a little bit more complex code, but it may pay off. And one more alternative that I would like to mention is GraphQL. Here, I would be a little bit cautious because actually what GraphQL brings you is a query language. And that's good if you can't predict what combination of attributes and entities you will need to work with. And in my opinion, this is an indicator, maybe not so much of a limitation of REST, because with REST, you also can have query parameters and you can have complex bodies that contain some queries. But it's more maybe an indicator of lack of business analysis, because you don't know what you will really need to do. And the consequence of using GraphQL can be that when you have a strong query language at your disposal, your clients might want to use it actually. And that means your clients will contain quite a lot of logic. And if you have multiple of them, then this logic may be duplicated instead of being placed on the server where it could belong. So be wary of that. Now, let's assume that we do want to use REST APIs. When you do something, you should do it properly. So you should understand the basics and not just imitate some examples that you find somewhere on the internet. So here's a notorious example, which is a pet store API from Swagger, which is nice, but actually here we can see that there's a URL /pet, and it's using the put HTTP method. And here we can see the body of the request, and it contains an ID. And now, why is it so? Probably because in some other operation, we need to have the ID either in the request or in the response. And of course, programmers like to do reuse. So we put the ID here. But what we are forgetting here is what is actually a URL. That's something that we use every day, multiple times. We type it into our browsers, and we forget what it actually means. URL is a uniform resource locator, and that's one of the two possible types of a URI, which is Uniform Resource Identifier. That means it should not only tell the machine where and how it should go to access the resource you need. It should also be a unique identifier of that resource. And here, what can we see? Slash pet. So we don't know which pet we are putting. And imagine, very probably you will also want to have a get endpoint that gets a pet. And there, of course, you would include the ID and the URL so that you can identify the pet. So you have an inconsistency. You have like two different resources, whereas they should be the same one. And of course, you can have a get endpoint that returns all the pets, but it would be very unusual to have a put endpoint that overrides all the pets in one request. So understand what REST basics really are about and try to use them to your advantage and not going against them. Another thing is when working with REST APIs, we need to name the resources somehow, and the REST itself doesn't prescribe how to name the resources, but we there are some best practices, because of course even in programming you could name all your variables var1 var2 and so on, and the program would work, but it would be very hard to maintain. So and one of those best practices is you should use nouns to name your resources. And why is it so? Because the method, the HTTP method, already is a verb, post or put or get. So for it to make sense, you shouldn't have two verbs in one sentence, right? And fortunately, the English language is very good at reusing words. So sometimes the same word, like order, can be a noun and a verb as well. So it is not very hard to use the nouns actually, and you can also generalize. For example, you can, instead of approve and cancel, you can have a resource that's called status. So you put the status, and the status can be approved or canceled. So you have many different options. Talking about REST principles, that doesn't mean you have to be like religious about it. There is something called Richardson maturity model that defines some levels of restfulness, and you don't have to fulfill all the requirements. One such requirement that is often not fulfilled is the hypertext as the engine of the application state, or HTOS. And instead of that, many APIs use a different way to tell their clients what the API provides. And that way is using the standard called OpenAPI. Now, OpenAPI is a way to declaratively specify our APIs. But how do we get this API specification? There are two main approaches. One is called code first, and the other one is specification first. In the code first approach, we basically write the code in our implementation language, for example, Java, and the OpenAPI specification is generated from that code. And that's so we have a formal specification. This works, but to me this is like using all fields public in a Java class, which means we are giving up some kind of some part of an encapsulation, because with this approach we mix things that are part of the API specification. They can come from the annotations. They can come from the structure of the objects that are passed as requests or responses. And yet there can be another places where we need to add some metadata that should be part of the Open API specification, and it's very easy to get for this to get out of sync. And another problem that can happen is that we make some changes in our code, and some of the we something gets into the Open API specification that we actually didn't want to have there. But of course, once something is published, it's hard to take back. So to me, code first is like using all the fields public. So it may be quick, it may be good for starting, for doing prototypes, but in the long term, to me, it is usually dirty, and it is good to invest in the specification first approach, where you generate code from Open API. So you generate interfaces in one folder, which is generated, and you have a manually written folder where you write the implementation of those interfaces. So you have clean separation between what's the API and what's the implementation. Another thing that can cause you a problem is that all the frameworks we use for creating applications usually provide very easy ways to expose APIs. It's like almost like a hello world in programming languages. The frameworks provide some kind of a hello world API, and very easily you can get into the situation that you are using the framework all over your code base, maybe in multiple services, and you are locked in the framework. We used to have Java EE, then we had it at its early phases. It was not so easy to use, so we got Spring. In the meantime, Java EE improved. It changed its name to Jakarta EE. We wanted to get rid of deploying to application servers, so we got Spring Boot. Then we wanted to deploy to cloud, and we wanted to start the application to start very quickly and not consume too much memory. So we got new frameworks like Quarkus or Micronaut or others. So how do we cope with this ever-changing environment and new frameworks coming? I think my advice is not to jump on the very newest, most cool thing, but also think about things that are like a little bit slower and have more support by multiple vendors that are a little bit vendor neutral, and those are the standards. So besides the Open API that I already mentioned, we have the microprofile standard, which is a subset of the Jakarta EE standard, and it's supported by multiple frameworks, the new ones like Quarkus or Helidon. So it pays off to pay attention to those standards and try to use them instead of features that are specific to framework, that just one framework. Another thing is it's also related to what I said about the code first approach, that it's easy to, if you forget about separating your API layer from other layers of your application, bad things can happen. Here we have an example of using database entity directly in a REST controller. And now many things that are very internal to your application can get exposed automatically in the API. Like, for example, you can have some IDs that you don't want to expose, or you can have some sensitive data. Here we see that we need to do JSON ignore to avoid some infinite loops in deserialization. So many things can happen. And especially if you have one too many relationships, this can also have a bad performance impact. So don't do this. Use the DTOs to map your lower layers to the layer that should be specific to the API, and first think what you really need to on the API and expose only that. Now, when we generate code from OpenAPI, we can also, of course, we can also generate the client code. And one idea that we can have when we are doing code generation on the server side, we can at the same time generate the client libraries and provide them to all the clients that want to consume our service in the form of some library or SDK. This looks like a good idea that can save someone something, but it goes against the idea of decoupling, because now we're forcing the clients to use the particular version of library dependencies. And of course, there can be clients that don't want to use Java at all, or and so on. Another thing is reuse in the API. It's the Open API itself. We should be also very careful there, because that also can bring coupling. One common case is reporting error cases. And for that, we have standards, actually, RFC, problem detail. So whenever there's something that you can use that is a standard, prefer to use that instead of your internal standard that will be hard to keep in sync. When talking about standards, a very basic thing about HTTP is the HTTP response code. And if you send OK in an error case, this can be very bad, because your client might throw away some data thinking that everything is OK. Again, if you return 500 and the problem is with the input, with the request, then the client might retry like crazy, and without success, of course, because the reason is that it sent something wrong. This is like a small thing that can be like a little bit of an over engineering, but in this particular case, I think it's may be more beneficial than the cost of it. If you return or if you work with some collections in JSON, the default way is to use the JSON array or list, but it can happen very easily that you need to add some metadata at the level of the whole collection, like pagination. And so for such cases, it's a good idea to wrap the collection into an object, so that you have a place to add these metadata without breaking in a compatible way, backwards compatible way. And when we're talking about backwards compatibility, that's another interesting thing, because we need all APIs need to change, and many people think that we'll just put slash v1 into our API URL and we are prepared, but that's not that easy. Firstly, it's not so clear to what change is actually backwards compatible and which not, because there can be clients who can be broken even if you make a change that should be backwards compatible. And again, if you put v1 or v2 in the URL, then it's not clear where. So maybe using a header might be a better approach. Okay, I'll speed up a little bit. We can there's again the other extreme is avoiding breaking changes at all costs. And like, for example, here we can see embedding schema inside another schema so that the official schema doesn't have to change. But this is very, very nasty because this embedded schema may not be documented at all and it's very hard to work with. So sometimes it's better to have a breaking change than just pretending. And the last slide is we all know the testing pyramid, that unit tests should be the most the type of test that we have the most of. But for APIs, it's a little bit special because writing unit tests for API specific code is many times is a waste of time because it doesn't test much. For APIs, usually the bugs occur in configurations and serializations and things that are usually skipped in the unit tests. So probably you should also pay attention to integration tests that spin up the real application and send real requests to it. And tools like Rest Assured or test containers can help you in that. So that's it.